This movie is on financial functions, some fundamental financial functions. We're going to begin by talking about the future value and the present value function that will return either the future value of an investment or the present value of an investment. And then we're going to look at three other functions that has to do with borrowing money. The payment function will return the payment for a given loan, or it will display the amount of money that you can receive from an annuity at a given rate. And the I payment function, the IPMT, will return the interest for a given period in that payment stream. And the PPMT function, the principal payment function, will return the amount of principal that's paid for a given payment in that payment stream. So the future value and the present value functions. I've got some calculations on rows 17 and 19 that are sort of the inverse of one another. Beginning with what I have on row 17. I have a return of 10% for an amount of money, a lump sum, that we start with in year zero of $3,855.43, so that I can set up some calculations and have Excel show me what the future value of this amount of money, this $3,800 invested at 10% a year, will be after 10 years. So year zero is, of course, the amount of money that we're starting with, the $3,855. Year one is that amount of money plus the return, which is 10% of the $3,855. Added together gives you $4,240, for which in year two we get a 10% return on, and so forth. So we have a compounding effect of the interest that's returned on the investment, so that in year 10 we have just under $10,000. We can have the present value function return that value to us to save us from having to schedule out all of those calculations. So I'm going to put a future value function in cell C28 tab. The first argument is the rate. The rate for us is 10%, but it's important to sync up the rate with the second argument, which is NPER, which is the number of periods. For us, the rate is associated with a year, and we're going to use 10% as the rate and the number of periods to be 10, since we have 10 years. But if you're trying to calculate the future value and your rate of interest is associated with a month, then you'd want to sync those arguments up and express the rate per month, and then the NPER would be the number of months. So since we're dealing with years and we have 10% per year, the rate for us is 10%, comma, the number of periods is 10, comma, the payment for us is 0, because we're not adding any more money along the way. We're beginning with a lump sum of $3,855, so the payment argument is 0, and the present value is, of course, the $3,855. That's what we're beginning with, comma. The second optional argument is the type. This type is associated with a payment. You are either making a payment, as far as the calculation is concerned, at the beginning of the period or the end of the period, which will then determine what sort of interest you're earning on that money. Since we're not making a payment at all, we're not going to define that argument. So I'm going to backspace and enter, and the future value function has returned exactly the same amount of money that I've calculated in row 17, column S. Now you might be wondering why it's showing a negative. That's because with these financial functions, there's a cash inflow and a cash outflow. And there's an inverse relationship between the two. So I expressed my cash inflow, which was $3,855, as a positive number. And because of that, the future value function has expressed the cash outflow, the money that is returned to me, as a negative number. To keep this more logically consistent, we would probably want to, and I'm going to F2, press the home key, make this a negative number, since that is our input into this investment, which makes the output, the amount of money that we're getting back, a positive number. I'm going to Control Z to undo that. And so that is the future value function. The present value function works exactly in the opposite way. The present value takes an amount of money that's defined in the future, and in this case, for us, it's $10,000. It tells us what the value of that money would be today. The discount rate that I've used in these calculations is 10%. So I've taken the amount of money that we have in year 10 and divided it by 1 plus the discount rate to give me the amount of money that we would have at year 9, and then taken that amount and discounted it again to give me the amount of money that we would have in year 8, and so on. So that I've discounted my way back to the same amount of money that we started when we calculated the future value of $3,855. We just inverted the process and came out, with the exception of a penny difference, with the same stream of values over this 10-year period of time, whether we're forecasting the future value of the amount of money or we're discounting that future amount of money to the present value. So once again, there's a whole lot easier way to do that by using the present value function equal PV tab. And once again, the first two arguments are just like the future value, where we have a rate and we have a number of periods. And once again, the rate has to be associated with the period. So since we have 10% that's defined for 10 years, the rate would be 10%, the number of periods would be 10, comma. Once again, we don't have a payment, so that's going to be 0, comma. And where with the future value function, we define the present value. In the present value function, we're defining the future value because we want the present value function to tell us what the present value is. The future value is, of course, $10,000, comma, and once again, since we don't have a payment, we don't have a payment type. Backspace and enter, and we get our $3,855.43. And once again, we have that inverse relationship between the positive inflows and the negative outflows. And in this case, the $3,855 is shown as a negative amount, which from a logical perspective makes sense because that's the amount of money that we're beginning with or putting into the process of this investment, and the $10,000 is what we're getting out, which is showing as a positive number in cell S19. So we didn't have a payment defined for either the present value or the future value functions that we just built. We're going to build a future value function using a payment, tabbing that into the cell. The rate, of course, is the same. It's 10%. The number of periods is 10, the number of years, comma. The payment, I'm going to make $1,000. And the present value, the amount of money that we're beginning with, is going to be $1,000. And the way I set up these calculations is that the payment we're making happens at the end of the year, comma. So 0 is the value for that optional argument, enter, and I get the exact same value that I have in cell S23, where we begin with $1,000 in year 0. We have a 10% return on that $1,000 and a $1,000 payment or an investment to give us the balance at the end of the first year of $2,100, for which we have a 10% return and another $1,000 added to the amount of money. And so on until the end of the year, we have an amount that equals $18,531.17, which is exactly what the future value function returns to us. There are 3 other fundamental financial functions that I want to cover, and that's the payment, the I payment, and the P payment. I've got a schedule set up that amortizes a loan and calculates the payments and the amount of the payment that is made up by principal and the amount of the payment that's made up by interest expense. Currently, it's not calculating anything that makes sense because I don't have a payment. The payment that's going to be fed into this schedule, I'm going to determine by using the payment function, the PMT function. All of the payments in this column, F2, are pointing towards cell C20, where I am going to build my payment function, equal PMT tab, the rate. I have an annual rate in cell K6, but what I want to do is determine the payments based on a monthly payment schedule. So I'm going to take that annual rate and divide it by 12, comma, and then for the number of periods, I have the number of years that I'm going to multiply by 12. So once again, we need to sync up the rate of interest and associate that periodic interest rate with the correct period, comma, and the present value is the amount of money that we're borrowing, comma, the future value, which is an optional argument. In this case, I'm going to enter 0 because we want to pay off the entire loan in 24 months, comma, and the type again, the optional argument type, defines when the cash flow takes place as far as the payment goes. I'm going to make it at the end of the period since that's the way I've built my calculation. Enter, and the payment function determines that the payment would be $4,614.49, which gets pulled into column N, and my schedule gets filled out so that at the beginning of this 24-month period, I have $100,000 that I borrowed. I have 1 month's worth of interest, which is 10% divided by 12, that's calculated on that $100,000. Since my payment value in column N has now been defined by the payment function that we put into cell C20, I can take the payment and subtract the interest and come out with what portion of that payment is principal. And then the way I chose to finish the calculations is to add the interest to the beginning balance of the month so that the following month I can take that calculated total and subtract out the payment to give me my new principal balance. So before we move on to the I payment and the P payment function, I want to go back and revisit the future value, which we determined to be 0, that argument. If we have a loan that we're making payments on, and the contract states that we have a balloon payment that's due at the end of, in this case, let's say 24 months, and that balloon payment is going to be, let's say, $20,000. In order to have the payment function take that into account, where we're borrowing $100,000 and paying 10% interest on that amount, so that at the end of 24 months, we still have a balance of $20,000, I'm going to backspace once and define the future value to be minus $20,000. And now my schedule shows after 24 months, the balance of the loan is $20,000, and our payments are obviously less. The value for the future value argument was a negative $20,000 because the balloon payment or the balance represents an amount of money that we still have to pay, which is an outflow. And money going out is negative, money coming in is positive. So we can then go to the I payment function and determine how much interest is paid for a given payment. Now we have all of that information in the schedule, but that's a long way to go to get what the I payment function will return fairly quickly. Equal IPMT tab. The rate again is our annual rate divided by 12 since we're dealing with months. The period, let's pick period 14, the 14th payment in the series of 24 payments, comma. The number of periods is of course 24, the number of years times 12, comma. The present value is the amount of money that we're borrowing, comma. The future value is that balloon payment, negative $20,000, and the type is, once again, when the payment will occur at the end of the period or the beginning of the period, and it's at the end. Enter. And for the 14th payment, the I payment function returns an interest amount of $488.74. The principal payment function, PPMT, returns the principal amount for a given payment. Building that, PP tab, the rate, well, we know what that is, divided by 12, comma, the period, I'm going to pick period 20, comma, the number of periods is the number of years times 12 because we're dealing with monthly increments here, comma, the present value is $100,000, the amount borrowed. The future value is negative $20,000 because we have that balloon payment again. And the type is at the end of the period, enter, and the principal that's paid on the 20th payment in the schedule and the return that we got from the P payment function is $3,541.55. So those are some basic financial functions. We started with looking at the future value and present value function, The future value will return what the value of a current lump sum of money is, given a rate of return over a period of time. And you can also include payments or deposits made each period to determine what the future value will be. The present value will take an amount of money that's in the future and discount it to give you what the current purchasing power of that future value is. After applying a discount rate, the payment function, PMT, will calculate what the payment is for a given loan, or a return would be for a given annuity, and the I payment and the P payment functions return respectively the interest that's paid on a given payment in a given payment stream, or the principal that's paid for a given payment in a given payment stream.